So you should already be in the folder and installed type EEG Lab Methods. Did you add your
Okay, so is everybody doing okay getting set up? All right, remember you want to open up EEG Lab, or excuse me, MATLAB first. So one way we can do that is we can come down here basically to the our start button. We'll see MATLAB come up, or I put it down. One way handy trick to do it is to put it right down here, make it a desktop icon. It brings up MATLAB like this. Okay, yeah.
Are we still loading the data set from last week?
We're not going to load that one right now, but that's going to be the next thing that we do. You can open up Mozilla and go to the box.com website that we had before, or open up your email and follow that link again and put it on like your favorite or save that link if you want. Usually Mozilla will start to autocomplete it for you. So let's just go back to that folder, and I added some data in there in the time since last week. And we can start to download that data, and if you might remember from last class, it takes a little bit of time to download the data. So let's start doing that now, and let that download work in the background, and then we'll go cover some new ground somewhere else, and we'll come back and revisit that once it's done downloading. So I can show you what I mean here on mine. And so let's, I just go to Mozilla here, and comes up. So I usually type in box.com. And it brings up a couple autocomplete things. Usually hit continue. Make sure you log in. Okay. And then it'll bring us to our folders. Okay. Now your folder is called EEG right now. That might change over the semester, but right now we'll just call it EEG. And you downloaded just about everything in here last class, except for this folder that I added new. It's called BDF. Okay, so all we're going to do is you just check that box there. It'll highlight the row horizontally, and then basically hit this button on the top left, which is the down arrow for download. And it'll say it, okay, it might take some time. And these are fairly big files. These are raw EEG files, and so we happen to record them at a very high sampling rate, and so it's a lot of data. And it takes a little bit of time to download, but that's okay. We're on a very fast connection here on campus. So this should be happening on your screen. If it's not, raise your hand. Okay, what were you guys able to do that? Okay. If I'm going too fast when I'm talking, I just like that. If I just zip through it, like it's okay. I'm expecting you guys to raise your hand and tell me, whoa, 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 slow down a little bit. Let me catch up. Okay, because if not, I'm just going to keep going through it. Yes?
You save a file, right? Or do you
You can save it.
I'm having a problem getting to this box through the email.
Okay. You can just type the link utdallas.app.box.com.
Yeah, that's another good idea. Top. You can just in your browser address, you can just type that link. What was it?
utdallas.app.box.com.
utdallas.app.com. That'll take you there. Then you just log in with your UTD credentials. Is everybody on board? Are you guys okay back there? No? Okay. It's okay. It's okay. By the way, like this is like a cool class to say it's okay. Like you don't need to, or I should say, it's okay to say that you're not where you need to be because that's really helpful.
Thank you.
Oh yeah, no, you're exactly right. You're good. Yeah, just. Oh, you don't want to. No. We want to go. No. Okay, now sit that little chip. Alright, how y'all doing back here? You guys good? Yeah, cool. Everybody else good in this room? You guys good? You guys good over here? Everybody's downloaded, it's all cooking in the background. So this is kind of like, anybody work in a restaurant? I used to work in a restaurant, so sometimes I use those as examples. It's like being a chef or a cook, right? You have orders coming in sometimes, or you can just cook it. It's like cooking at home too, I suppose. I don't cook at home very much. But some things take a long time to cook, and some things take a little time to cook, and you need it all to come out at the same time and be warm and delicious. So this is like a thing that takes a long time to cook, so let's start it, put it on the back burner, and we'll cook some of the other stuff in the interim, and we'll come back and revisit it. Okay, so we have this downloading. You can minimize that. We talked a little bit about on my MATLAB window. Okay, so we have MATLAB here. Okay, so I haven't done anything in MATLAB yet. All I did was just open the program. So the first thing we're going to do is what when it's open? Exactly, set path. Anybody remember what setting the path does? Exactly, it tells it where to look to do the things that you're going to ask it to do later. Basically, when you call commands and functions and files, it's helpful. If I tell you, go pick up those groceries, right? Probably the first question you're going to ask, besides like, why, what the heck are you talking about, is going to be, well, where? Where are they, right? There's groceries in all sorts of different stores in town. So you want to know what store to go pick up the thing at. So same sort of idea. It'll take us to this directory here. Within set path, we want to add with subfolders. Okay, so with subfolders, what it does is it doesn't just add that one place we want it to look, but it includes everything within that spot that we select. Okay, anybody remember what we select? Yeah, okay, so we came up here and we just selected our EEG folder. Okay, so we selected that, and we don't hit save because our administrator rights on these computers are goofy. If you have it at home, then you can hit save and you're good and you don't have to do this again. But for now, we just hit close. It'll ask us, do we want to save it? And we say no. Okay? Everybody good on that? Has everybody done that?
I ended up hitting save, and it like popped up with some like don't do that box.
Yeah.
And then I closed it, and it looks like it all opened up.
Yeah. Okay, cool. So, what's the next thing we do? Browse what? This little guy, right? All right. So what does this do? Browse for folder. What is this? What's the intention of this command in terms of if you were teaching your little brother or sister what's happening in your college class? What are you going to tell them that this is going to do? It just sets your directory for where you're going to pull your files from. Now, what one thing you can notice is we have. Right now, at least I have our default is whatever it is, your user folder, documents, MATLAB, and on the left-hand side, it shows us what they call current folder, and it shows us the stuff that's in here. Right now, there's just this one file, and so what we're going to do is we're going to basically navigate to the folder that we want, which is the same one from before, EEG. We hit that and select it. Now look on the left-hand side, all these files showed up because those are the files that are within our folder. Okay? Does that make sense? Is anybody not exactly here? Okay, what do we got, Val? Yes. Yep. 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 No, that's fine. Yep. That's perfect. Cool. Okay. So. Everybody's on board? We're good? Same page? Okay. Like I said, it's totally cool to just say, raise your hand without me asking and be like, hey, just give me like 10 seconds, let me catch up or whatever. That's actually really helpful for me because then I don't end up chasing stuff around expecting that everybody's further. Sound good? Okay, so here we are. We have all of our files in here. Now, let's do a couple little... So first of all, if we want to open up EEG Lab, what do we do? Yep, type EEG Lab. Well, you got to actually... you got to be in the command window. EEG Lab. Okay, and that brings up our blue box here that we call the GUI, right? Graphic User Interface. Fantastic. So we have that, and let's see here. What did we do last time once we got here?
Loaded existing data set.
Yeah, so we loaded some data and we played around with it. We talked about finding some links in the brain data and all that kind of jazz. While our downloads are working in the background, I want to show you guys a couple shortcuts, a couple little tricks. So what are some other commands that we learned to type into the command window here last class?
CLC.
CLC was one of them. What did that do? It cleared our command window, right? And then somebody said clear all. Who said that? Yeah, okay. So what did clear all do? It cleared everything in our workspace. Okay? So let's just, you can watch what I do, you can do it with me if you want. So if I'm in my command window, let's just say I type in CLC. It cleared my command window, but all of our variables, okay, that's what we call this stuff here in the workspace. We had a bunch of variables, sort of like an algebra equation, okay, because that's kind of what MATLAB is doing. It's doing math equations on matrices, and so some of that involves some algebra, so we call it variables. So all of our variables are still in the workplace, okay, but let's say that we're like, oh crap, we screwed everything up. I just need to start all over, okay? You want to clear everything and clear all. So if I type that in, now that clears out the workspace too. Okay, so sometimes it's helpful to do that on different occasions, and I'll show you a couple small, easy things we can do to make this stuff a little bit more accessible and easier. So one thing we can do is we can create some shortcuts. Okay, so notice we have all these little like shortcut buttons up here. We can add them and we can make them ourselves. So these are just little tricks that I like to do that help me process data that I figured you might like too. So see this little button up here? If you hover your mouse over it, it says create new command shortcut. So if you snag that once and you just hit it, it's going to bring something up. It's going to ask you to give it a label. Let's call it EEG Lab. So what this is going to do, this is going to give us a little shortcut button. You just hit once and you'll never have to type EEG Lab in again. All right? These are little things. They're going to save us little fractions of seconds and make things go a little quicker for us. Okay? And what you do is it asks you to type in a code of what the actual callback information is. So in this case, all that it's representing is just the command of EEG Lab. So we type that in again. Now, some of the background information here is that we could call this any name we want. We could call it, I don't know, UTD comment EEG Lab, and it's still going to bring up EEG Lab because this is what the actual nuts and bolts, this is the skeleton, the inside of the code that's going to be commanded. Okay, so when you hit this button, it might say a goofy name up here. You can type it whatever you want. I don't recommend anything but EEG Lab, but it's always going to call whatever you type and save in here. Okay? So, and we'll talk about that as the class goes on. You can write big, long code and just be able to hit it once. Okay? We'll get to that though later. And let's see here. It'll be, I wonder if we can change the icon. You want to make it, let's make it a little MATLAB icon. Just so it's nice and colorful. Hit save. Okay, so now that's up there. All right, let's add, why don't you guys go ahead and do that again for clear and CLC. Or clear all and CLC. Okay, and you can watch me, I'll do it too. I do that. And I want to make. I like making him colored, the MATLAB icon, but that's just my call. You can do whatever you want. I can edit that. Anybody having trouble with this? So these are just examples of little things that you can do. So as you move through the semester, you can start taking your own autonomy. And if you find things that you find yourself through the semester, you're always typing in the command window over and over again, you can take your own liberty and just create your own shortcut buttons or whatever it is that you desire in your own data analysis. But I just wanted to use these as small examples for that. By the way, how many people decided to try to get a copy of MATLAB for themselves at home? Yeah. Okay. Most of the people. All right. If you don't, I mean, it's okay. You can certainly don't have to do it necessarily, but both me and the students who took the class last semester found it extremely helpful to working with data and projects outside of class. Yes.
Do you recommend if we do it on our own personal laptops, if we bring our laptop and work on it in here?
Yes.
Okay.
Yes. If you put it on your own laptop, it's just going to be easier to bring your laptop. Don't even open up these screens and just do everything on your laptop. It's just easier to have data centralized to one place, but it's totally fine if not. You know what I mean? Yes, ma'am.
My doing really goofy. It sounds really good.
It's goofy. Uh-oh. Let's take a look. Well, clear and CLC are different commands, so you should not do that. Clear all should be clear all.
Well, I don't really do that.
Okay, you just type CLC. Just do that. Okay, that's fine. Yes, well. No idea what's going on. Just type in CLC. Yeah, so we can work on shortcuts later. Okay, so we got this idea of shortcuts. We can get to that, and we'll do a couple other little tricks about that as we move along. So, a little basic intro and overview there for some MATLAB programming. Okay, let's see here. So, let's hit the EEG icon, and it should bring up EEG Lab. Okay. And then we loaded a data set, right? And last time what we did was we did load, and then we grabbed one of these, we grabbed the longest named file there, and we loaded it, all right? Let's see.
Is that the one that says ICA?
It does. It does say ICA, and we'll talk about what ICA means as we get along through a processing pipeline. But have any of you guys taken my class in behavioral neuroscience? A couple of you guys? So you guys know, where do I like to start? I'll give you a hint. It's like Drake. Ah, at the bottom, yeah. All right. Okay. So, yes. Here, actually, you can close out of here. So I was just showing you where we went to last class, but we're going to start instead. So when we had this big long file name here, this is data that basically I've already done a whole bunch of processing steps for, just so that we could play with it last class and be introduced to it in a more direct way that got you some hands-on stuff. What I want to do, as I was alluding to a minute ago, is start from the bottom, sort of like Drake. Now he's here, and if we basically we'll start from the very base level of data analysis, raw from essentially the recording session, whenever that data collection happened. Okay, so it doesn't start off in this clean way. So one of the things we'll talk about is how we name files. Okay, so this is a really long name, and every time that there's an underscore here, the style of naming that I use means that every time there's an underscore, it means we applied a different function to the data. Okay, So we're going to start at the very base level of data here, okay? And let's go back and X out of here. And what we can do is we can import data, okay? So everybody hover over here. You see this little thing. We're going to go use the biosig interface. Actually, what we can do is let's do this: biosemi BDF and EDF. Okay. When you select that, you grab the only BDF file that there is. I'll show you again. You come to File, Import Data, EEG Lab Functions and Plugins. So the top one in this row. Go right in sort of the let's just do, you can do biosemi BDF file, okay? Grab BDF, open. And it's going to start doing things for a long time. Oh, well, it will in a minute. Okay, so what we're going to do is, yes ma'am. Which what? The only one that ends in the letters BDF. It's just 3.BDF. Are you good? Yes, of course.
Can you go back to the file section?
Sure. Cancel out of there. It's just this one here, 3.BDF. It's the only single one that there's an option for. Well, so this is a really good question. So there's always going to be this one, or there will be other ones. We're just doing that one today, and here's why. So, and this is, I'm going to use what our walkthrough is of the data to introduce you to what the experiment is, and to what the experimental setup is, and how it's organized. And when we talk about that, it's going to give us an opportunity to gain some insight into what are the issues at hand about memory that we're actually studying, and how are we doing that with experimental design and all those types of things. Okay, so number 3, what does number 3 refer to? So when we're recording or running these experiments, we basically have a sample size that we're going to use. The big letter N means sample size. Okay, we're going to have 25 people in our experiment. Okay, we call them subjects or participants or whatever. And so you number them, say 1, 2, 3, down to 25. Okay, so we always start with naming the file by which subject it was. So in this case, we just happen to be using person or participant number 3. Okay, so what are some of the reasons why we want to use, say, a relatively big sample size like 25 people as opposed to 4 people? I'm sorry? Okay, so you can generalize your data is one reason. What's another reason?
It's more statistically sound.
Exactly. So it gives you a little bit more ability to have more statistically sound conclusions that you can draw from the data. So what do we mean by that, statistically sound?
You have more data to support that what you're seeing is actually more common than just this one person.
Yeah, okay, so you have more data, so you have a little bit more reliability to know that the results that you're observing are can be generalized to beyond just one person or 2. Okay, so I'm going to come back and revisit that point in just a minute. I want to make sure everybody grabs that number or that file, right, and open it, because it's going to take a moment or 2 to open. So we can talk while that moves. And it's going to give you this blue box, and what you're going to do, you're going to ignore most of this stuff, okay? And what we're going to do is just type in the number 33 and then space bar 34. And I'll explain what that means in a minute. Yes?
I don't have the same Dropbox box.
Did you do what we did? Okay, Ariel, do you think you could help her?
Mine is different too. I can't help it if I'm different if I don't do that either.
Okay, so
So you need to import data. So you could speak it, right? Is that what you did? Right, so that's what you do.
okay, is everybody else here? All right, so just type 33 space 34 and hit OK. And it'll think for a while down here, and it'll tell you what's happening. And while it thinks, we're going to think. Okay? And so let's talk a little bit more about what we had. We had subjects 1 through 25 because only 1 or 2 subjects, yes?
I have an error. It didn't shape the number of elements and not change.
Did you do exactly what we did?
Yeah. I don't mind. I don't know why it's not. Download it. It works. Sync, you just didn't do it.
And then did you click on the whole video, or was it just the? Yeah, I think it's just something in that did it wrong by or whatever. Yeah, I don't know about it, but, oh, so 33.
I'm not sure. Yeah, I have a different one. I don't know why you have a different version, because areas that on the actually outdated, because I have the 2015 version.
Do you have the 2015 version?
This is not the 2015 version, this is 2012. Yeah. So, she's gonna have to work with you, but can you work with them on that? Get that situation, because I can deal with it.
So you need to pick one or the other, because if you're working on 2015 version, that's going to be different. But
Okay, so let's talk. Ariel will help. Are there any other people that are having trouble with this other than that group over here? Okay, all right. Let's talk a little bit about what's happening while this is going on. We have 25 subjects as opposed to just 1 or 2. Okay, that's really helpful for a handful of reasons. Okay, so we're going to talk a lot about this idea that we call signal to noise. Okay, so what is our signal here?
The ERP?
Not the ERP yet. The signal is EEG. Okay, so what's the difference between EEG and an ERP? Yes, ERP is an averaged electrical potential. Okay, so we can talk about that here. And let's talk about exactly what's happening. All right, you've got a person hanging out in an experiment. Okay, now we're recording electrodes from all over the head, right? I'm just going to put these little circles here representing these little electrode spots. Okay, now it turns out there's 32 sites. Okay, now our 32 sites are obviously recording from a cap that hold them in place from the same spots of everyone's scalp. Okay? Now, when this is happening, each one of these electrodes is recording a pattern of activity. Okay? Okay, and that activity oscillates. It goes up, it goes down, does all sorts of wacky stuff. Okay? Because the person is alive, we hope. Okay? Flat lines are bad. So, every single one of these is going to have a different trace. And because we have 32 electrodes, we can number them 1 to 32. Now, we typed in 33 and 34. Why? We are looking at those, well, we're not looking at those two electrodes at 32, or excuse me, 33 and 34, but I said that we only have 32 electrodes. How did we type in 33 and 34?
We're creating new ones to
Ah, it's a good idea. We might be creating new ones to analyze, but actually what happens here is we're recording from 32 regular electrodes here, but what we do is we actually set the participant up to have more than 32 electrodes, okay? We'll get to this in a minute, so I got done thinking, and maybe we'll get done thinking in a minute too. Let's finish the thought that we were working on. So we're recording from our 32 channels, but what does the electrical activity mean? Okay, this is a really, really important aspect of EEG and ERP data analysis, is that in order to basically have the data be meaningful, it has to be referenced to something. Okay, so some of you guys, if you guys are interested in like electrical engineering or any types of like, I don't know, interests, you might maybe pick up this idea a little bit easier, but the idea is that we always need a reference. We have to have it in comparison to something, okay? You can use different sites that you'll compare to, but for us, we record 2 additional electrode sites at what we call the mastoid site of the head. What the mastoid is that bone right behind your ears. It's not like the fleshy part by your neck. It's that like weird bone that's back there. And the idea is that it won't pick up very much specific. It won't pick up as much brain activity directly. It'll pick up more sort of non-neural activity there. Okay. Now, people use different types of references. You can use a central reference up at the vertex of the scalp. Sometimes people use the earlobe because it's just going to be, it's obviously not going to have as much brain activity happening. That's, you can record from there. Some people even you can use the tip of their nose. But what happens is because everything that you look at here, right, it's just a measurement of electrical activity that's either up or down, right? And so when you measure it, it's always in comparison to something. So what does that mean? Is that it means that that value is going to change based on what reference site you use. Okay, so when I say some people use the nose or the earlobes or the vertex of the scalp, it can be research specific and field specific because so we're going to use data that works with memory. In the memory field of EEG, people tend to use the mastoid sites. Therefore, we want our, God bless you by the way, we want our results to be as close to consistent with what everybody else has so that we can compare it properly. Yes?
Why wouldn't the site on the top of the skull pick up a lot of brain activity?
Well, it most certainly does.
It's just a different level for a different reference point?
Yeah, it's just, we can, there's a lot of discussion about this in Steve Luck's book that we have assigned for the class. You can dive in deep to those issues, and it's just about having a central site that you can basically subtract from the data. So you have an equivalent spot that all the data is referenced to. Sometimes people do average. You just average all the activity or something like that. So what we do is we average the activity between both sides. So it's not lateralized. That's why we typed in 33 and 34. Those are the numbers for our mastoid electrodes. Okay? And we basically tell it, import the data, and the very first question it asks us is, well, how do you want us to import it? all these ones and zeros, these measurements you've taken of electricity, what do you want it to be in reference to? And we said we want it to be in reference to the average of the two mastoids. So we typed in the number for both of those channels, 33 and 34, and the computer then knows to average those two together as the reference. Okay? Yeah, you're right.
How many people have MATLAB 2000? Because it's a bug. It's definitely a bug. How many people have MATLAB 2015 on their personal computer? Higher, raise your hand high. 1, 2, 3. Did you get it from the tech store?
It was online.
Okay.
But was it from the tech store? Did you pay $1,000?
Yeah. So I'm going to suggest that they stick with 2012 because you got it from the tech store.
Yeah, 2014 works too.
It does?
Yeah, I used 2014. But
Because I'm going to have to get 12 or 14.
What is the text store at?
Well, you got.
It's 2000.
It's 2000. I just got it yesterday.
But it's not that they have it. They just give you a product key, and you choose which version you want to download. But when you install MATLAB, it asks you what version.
We should have installed the 2012.
It could be 12. Like I said, I think I have 14. 2014 works too. Yeah. So, but you guys have it working on your desktop here, right? I mean, every single desktop here should work. We've done this in other classes before.
Right, yeah.
Okay.
So don't do it on your personal machine.
Yeah.
This version is 2012 then, that we're using?
As far as I'm aware, the desktops are 2012, and you'll know that because it says it right on the MATLAB name on the top left of your screen. Okay. So yeah, I mean, I use 2014A. That works. But you know, like I said, the course is designed to operate in the class here. But if you want to do it outside of class, people have found it helpful. So anyways, we have our average reference electrodes, 33, 34, and we tell it to do that, and then it does it, it thinks, and it loads it in, and it asks us, what do you want to do with the new data set? Okay? And we say we want to name it, so that's the first thing we want to do. Let's just name it, we'll come up with something now. So we'll always start with subject 3, so we know who it is, underscore, you guys paying attention? Okay, 3 underscore, what do you think would be a good name? Maybe imported, right? That's what we did, so we imported it. And let's say 33, 34, okay? Just so we know that it was imported reference to the 33rd and 34th electrode site. Or the left mastoid and the right mastoid, LM, RM. So if we just do that, just for basic sake, now we have that loaded in, okay? So let's talk a little bit more about this data that we're getting. Okay, we have all this data coming in. Now we have this loaded into our MATLAB workspace, and it's representing this activity that's been referenced. Yes, Val?
Should we tick the box save it as file? On the previous window, we named it.
Yeah.
And there was a box, save it as file. So you do that. I've looked down and
The OK button?
no, this one here.
No, you don't have hold on. It shouldn't be, I don't know why you have 2 data sets though. You want to record it using a different function. Where did you first data set? Oh, okay, so you wrote it together, that's fine.
Okay, so now one of the things that we notice is that we started with 0 data sets. Now we have a data set. You should be able to hover over that. And we can see that now we have that data set. We can see they call it data set 1, and then it tells us, well, what's the name of it, okay? And we'll always know that it says it here too. Okay, so in our GUI, it tells us what are we working with. Now it tells us all the stuff. We have 38 channels here. Okay, it tells us how many epochs. So an epoch is a time. Okay, so we have 1 time. It's 1 long time of data. All right, it asks us how it tells us there's 900 events. We'll talk about that in a minute. Okay, it tells us our sampling rate is 1024 hertz. It tells us our reference sites, the left mastoid and the right mastoid, LM and RM. Okay, It tells us we have not loaded our channel locations yet, so all they know is that each one of these is listed as a number. It doesn't know the spatial coordinates of where that is on the head yet. It's just math at this point. It just looks at it as numbers. And we will talk about ICA a little bit later in the class. And it tells us the size of the data. So a lot of the basic information of this data set is given to us right here in the get-go. Okay. Yes? Channels per frame. This is just basically channels per frame. What they're referring to is how many basically electrodes do they have identified. So here they have 38. Now we also said that we started with 32. Well, that's weird. But then we said, oh, well, there's actually a 34th and a 33rd mastoids that we referenced to. But we also have some electrodes that you already know about. Beyond our 32 brain site electrodes, we have those eye electrodes that gave us those blinks that we saw last class, remember? So those are basically recorded one here, one here, one here, and one here. Okay? The reason that we have each of those locations is now we can detect basically movements to the right, movements to the left, and then of course up and down. So you've got these, all four of the sort of polar coordinates. So we basically can track the eye movements, and you know why that's important because we already saw that last class. Okay? So this is called EEG, right? Yes, sir.
Are those two up and down electrodes, like specifically on the left eye for any reason? Or is it just...
Right now I just do it for conventions, what I always do. It doesn't have to be the left eye, it could be the right eye. But that's just the way I've done it for 10 years. But yeah, it could be either one, because most people's eyes kind of work the same, right? Unless you got some really super cool powers where you can like... Right, okay. So, EEG, what does that actually stand for? Electroencephalogram, right? Electroencephalogram. We shorten that for EEG, okay? Electrical encephalo means what? Brain, right? So Greek etymology for brain. And gram, of course, means measurement, okay? So it's measurement of brain activity. Duh. All right? These sites over here that we talked to, these ocular electrodes, we actually call that EOG. What do you think that refers to? Yeah, electrooculogram. So we have EOG, electrooculogram. Okay, obviously we're measuring eye activity there. Now, when we have these four EOG sites, we actually, I was going to ask you a question, but you should know the answer from last class, is we have extra letters that go along with them. We call them additional names, right? They're descriptors, so we know which of these four electrodes each electrical trace is referring to. We have the HEOG, the VEOG, right? You guys remember all this? Vertical, upper, UVOG. Okay, so you have, basically U, V, H, all that kind of stuff. So we have four of those plus our two mastoids. Okay. 4 plus 2 is 6. 6 plus 32 is 32. Or excuse me, 38. Okay. So there is a method to the madness. Okay, I guess maybe that's a really good central theme for the class, is that when we're working with all this data, this ones and zeros, it looks like a big gobbledygook and crazy stuff. There is a method to that madness, and it means something. So all this stuff, 38, it means something specific, and it's usually for a good reason. Okay. Sometimes I know what those reasons are. Other times I don't. Ask, and I'll tell you. At least I'll tell you either way. But I will like to share with you the things that I do know for the next semester or so. So we have this sort of basic setup. What else do we have? What other type of E something G is also being recorded when this is happening? Is that all we're picking up here? You put a bunch of electrodes on a head. Are we picking up straight brain activity and every now and then a little bit of eye activity? Nothing else. Just clean slate. So what else are we picking up? Huh?
Noise.
Okay, noise. Like there's a band in the background that jamming out. What kind of noise?
Like a screen.
Like a what?
Like a screen or
A screen? Okay, so a screen's a really good point. We'll get to that actually. Oh, you mean you? I think what you're referring to is noise from the environment that you might use a screen to make a Faraday cage with to filter out. That must have been exactly what she was thinking of. Well, why'd you say screen?
Like I'm not like a screen. Like,
Oh, that kind of screen.
yeah.
No, okay.
Like, what about like a phone or something that
Yeah.
makes it phone?
So we're actually talking about the same thing.
Okay.
You don't know it, but we are.
Alright.
So what she was talking about is there's electrical noise from the screen. Okay, there's the screen is obviously electrical. There's electrical noise from the light. So things oscillate. So we talk about this idea of oscillations, right? We have stuff that comes up and down, right? Everybody here has had behavioral neuroscience with somebody, right? So we know about auditory waves, we know about visual waves, right? Photons of light are at certain wavelengths, frequencies, auditory sounds come at certain wavelengths, and certainly we're talking about brainwaves here too. But light, auditory, light, visual, is certain photons that are at certain wavelengths of light, which represents a certain oscillation. It turns out most of our lights and computer screens are very specific with what we call line noise at 60 hertz. So when you plot, let's say that we graph this way, frequency. What's our measure for frequency?
Hertz.
Hertz. Like the rental car? Huh? Like the rental car? Yeah? Okay. So, we start from 0. Let's say we bump it up to 100. Okay? Roughly 50. We mentioned 60 hertz line noise. So, if we're graphing this type of frequency, we're going to see, if we plot it, let's say, a lot of times they graph these things with color maps or heat maps. We'll get into that in a little bit more detail as the class goes along. But you'll see this patch of 60 hertz that sticks out. Okay? Maybe I should just color it this way so it doesn't look like oscillations. Okay? So if anywhere on this, say, heat map that's colored represents frequency of activity, and anywhere that's not colored is neutral, so we have empty space here. We're just showing 60 hertz line noise. So you might have noise like that. That's also something that might be recorded, absolutely. We also have a different type. Now, most of brain activity is going to happen under, let's say, at least in the ERP, under about, say, 30 hertz. Okay, that's a lot of what we're going to be interested in. And so we don't really need a lot of this stuff north of here. We're going to focus on most of this stuff south of here. In particular, a lot of the brainwave frequencies that a lot of people look at. Okay, you can further divide them between different segments. Okay, and we give different names to them. So let's say 4 hertz down to 0. We call that delta. Very slow waves. Delta. By the way, what's hertz mean?
Cycles per second.
Cycles per second. Okay, what do we mean by cycles per second?
How many times something occurs per second?
Exactly. So if we have this trace of electrical activity, let's say that this is 1 second in time. So everything in this class we're going to be talking about time, 0 to 1 second. Okay? It means how many times does this signal make a full revolution in 1 second? This is a very slow one. This is a very fast one. All right? It's basically sine waves. You guys know about sine waves? You remember that from math class? That's all it is. It's how many times do we start from here and get back to the spot of where we started for a full revolution. Everybody on board? And you measure that, and if it goes a lot, then it has a higher number. If it has a little bit, it has a lower number. 4 hertz is about delta. From 4 to about 8 hertz is theta. Okay. 8 to about 12 is alpha. All right. And then 12 to about, I don't know, 30 or so, if I think off the top of my head. No, it's beta up here. Okay. So, and you can see different patches of that at different times. So the brain oscillates in different frequencies over time. All right. This is a general overview. We'll get into this in more specifics. But the idea is that so there's noise. So we have EEG, EOG. We also have just let's say line noise, 60 hertz from the lights. And what I was speaking of when we were having our conversation a moment ago was there's ways that you can actually account for that. So if you're building a laboratory, one of the things you want to do is you might want to make what's called a Faraday cage. Okay, it's a cage, literally like basically a wrapping of an electrical screen that if you basically wrap your recording room in, it shields the introduction of any other external outside noise. And that's based on some electrical properties that you don't have to bother with for this class. Just know that a Faraday cage can basically create an electrically shielded chamber so that you don't have that other stuff outside of that. And so some people literally, they just make a big wooden frame and you'll just staple screening to the outside of it. I had a supervisor in my undergrad, he had a new building being built when he was hired, and so he had them build the screen into the building blueprint plans, the EEG recording room. It's pretty cool. So you can do things like that, help to give you a cleaner signal. You don't want all this crap coming in. Okay? So what else do we have? EEG, EOG. We also have something called EMG. Anybody have an idea of what EMG might be? Electro what? Myogram. Okay. What does that mean? Electromyogram. That would be an EKG, which would be an electrocardiogram. But that can also be recorded too. Okay. Sometimes you can see EKG too. Particularly if you put the mastoids on the wrong spot and it goes a little bit closer to your carotid arteries, you'll catch that heartbeat pretty good. Okay, so we could definitely catch EKG, which is basically electrocardiogram. Electromyogram, though, muscle activity. When you're blinking, it's actually one of the things you're picking up. You have your muscles squeeze and relax, clench their jaw with all this temporal muscle tension. They yawn, but they try not to blink by scrunching their forehead up. You get all this really tense muscle activity, and that tends to be higher up on this spectrum. Pretty high frequency stuff. Not there, if not higher. So we care about the brain. We don't really care about the muscles. So we'll talk about ways that we get rid of that muscle noise. So the idea here for this sort of mini lecture on these topics is we have all this stuff happening, and so instead of these nice clean signals, what we get is a singular signal for each of these electrode sites that just mushes it all together. Okay? That's fine. We're detecting all these things. We'll talk about ways that we can pull them apart to get cleaner signals. But what we want to do, and why we want to have many subjects, say 25 subjects in this case, people in the data, is because we want to be able to average this, and this is the very idea of what an ERP is for every person, you average their data together, and the idea is, in the averaging process, you will eliminate the noise. So if you average enough trials together, all this crappy noise will average out, and you'll be left with whatever the signal is. That's the idea of an ERP. Is everybody on board with that idea, conceptually and theoretically? Okay?
So
Yeah.
So all the little ones, or not the little ones, but all the individual ones are like from the EEG config.
What do you mean by ones?
The signals.
Okay.
And then the ERP is just what you're saying that it averages all of them.
Yeah, so, well, what the ERP is, so our which I should say is our raw EEG trace. So if you go to, you can just do it now. Go to plot, channel data scroll. Okay, and so what we see here is looks a lot different than what we saw last class, doesn't it? Yeah. Okay, we have our electrode sites here, but the scale here is very different. Let's type in, I don't know, I'm going to put in like 400 maybe. So now I can start to see all these other channels. Okay? So, this scale is massive, 400. Okay, I'll even type it up to try 800. Okay, we can start to see how, but of course, the reason I say this, the reason we did this was to answer your question. Each of these electrode sites still only has one trace. Okay, so if we go back to, let's say, 75, okay, I'll bring it down to 40 if you want. You can see this looks like what we would expect our EEG to look like, right, when we zoom in a lot closer. Okay, so here we have a singular trace from a singular electrode. Okay, and it looks just like I said, we have one trace, but that trace represents the amalgamation or combination of all these different factors. Does that help to clarify? Okay, so that's in an EEG, and that's different than an ERP. Okay, what an ERP is, on the other hand, is, let's say that, oh, this is really nice actually. So we have 1, 2, 3, 4, and I guess a 5. Let's pretend that every time there's a number here, it represents something on the screen that you either remembered or forgot. Okay? And so what we want to do is we want to average activity for each of these epochs. Remember we talked about what an epoch was? Yeah, it's just a time period. So if you talk about the Middle Ages of history, that was an epoch of time. Your freshman year is an epoch of time. Our epochs are going to be 1.5 seconds. Okay, so every single one of these epochs represents a different period of time. And what you want to do is slice the pie. So remember we said, in our GUI, we say we have one epoch. But what we're going to do is demolish that. We're going to slice that pizza into 300 slices. So we have 300 trials of memory experiences in our experiment. So we need to slice the single one long trace into 300 slices. So when we slice it 300 times, we'll have epoch 1, epoch 2, epoch 3, epoch 4, epoch 5, etc., etc. You guys follow? Now, this is all, let's say, for electrode AF4, anterior frontal electrode number 4, anterior frontal, right here. Okay, so this is just one electrode. Electrode for, let's say, 1, 2, 3, 4, 5 trials. Trial 1, trial 2, trial 3, trial 4, trial 5. Everybody confused? Okay, so what the ERP is going to do is say, let's take the average of all of these. You guys know if I use this sign, the M with the bar over it, that means average, the mean. Okay? The average of that might look something like that, maybe. That's an ERP. Now we have an electrical potential that's related to a particular event. And this event, let's call remembered. All of these were trials in which the person successfully remembered information. Now what we can do is now I'll say a second, well let's use a different color, which is green, this red's kind of crappy. A second electrode, called electrode number 2, also has 5 trials. Okay, so the second electrode, let's say, actually, you know what? Scratch that. This is the same electrode. Same electrode. The black, 5 trials equals when they remembered stuff. Okay, and the green equals times when they forgot. Pretty simple. So now we're going to look at a different 5 trials that they forgot of. Okay, so let's say these 5 trials, trial 1, trial 2, trial 3, trial 4, trial 5, each of these they forgot. Then we take the average of that. Let's say that looks like that. So now you have the average of 5 different trials at the same electrode site in the same person. Everybody on board? Okay. So we can label this as basically forget. This is an ERP for forget. And this is the event-related potential for remember. Okay? What does this tell you?
There was one negative bit.
Yeah, so it tells you one really important thing right off the bat. Brain activity is different between when you're remembering or forgetting. Right? So when we start with scientific experiments, we start with what's called the null hypothesis, which is the hypothesis that there are no differences between our conditions. Okay? I always like to talk about it in the context of there's the hypothesis that if you spend $200 on Air Jordans, they will make you a better basketball player. Who believes that hypothesis? You do? Yeah. Lots of people seem to, because they're, they buy the shoes, right? You want to be like Mike? I don't know. You guys might be too young to remember the commercials of Be Like Mike. It was a big thing in like the 80s and 90s when Jordan was jamming. Anyways, a lot of people want to be like Mike. You buy the shoes, you think you play better basketball. Of course, most of us probably assume that's probably not the case. But that's the null hypothesis. You take somebody with Jordan shoes, somebody without Jordan shoes. You say, okay, shoot some free throws. We'll see. A null hypothesis. Or you take the same person, you give them Jordans, you give them not Jordans. You measure how many free throws they make, let's say, out of 10 shots. And a null hypothesis is that they will not differ in the amount of free throws that you make based on what's on your freaking feet. Pretty reasonable hypothesis, right? There should be no difference if you plot those bar graphs. Now, that's our hypothesis here too. If we just record brain activity, right, the hypothesis that we start with is that the brain activity should not differ based on whether you're remembering or forgetting. You can come up with some reasons why that might be the case. Maybe this is not a sensitive enough measure to capture memory. Maybe memory is just a fuzzy psychological phenomenon, and it's not biological. Right? There's lots of reasons you might pitch that null hypothesis. And what this shows us is exactly what you came across, right? Somehow, though, in contradiction to the null hypothesis that there's no differences, it seems that the brain is differentiating between things it remembers and things it doesn't. Okay? So what we do is we then subtract the average mathematical, and just in math, you take the amplitude measurement from a period in time, let's say between these latencies, and you can mathematically just quantify it. What's the average electrical value there in this line versus the average electrical value here in this line? And if you graph that, you might see that, right? You can plot it like this. All right, so this would be your remember, this would be forgot. Okay, this would be at your anterior frontal site 4. And we can see that this looks like a pretty big difference between the two. Yes, sir?
Is there any, what's the method for choosing what two latencies?
Ah, very good question. How do you choose what two latencies? Any ideas? It's the same way that porcupines make. Very careful. Yeah. You ever heard that before? Oh man. That's an old one. Very carefully. Basically, if you start what's called a fishing expedition, just poking around and go, well, I'll grab that, you end up having some statistical problems, because what you want to do is very carefully approach this based on, the best way to do this is based on the existing literature. So when you would write up your results sections, you would say, we chose to focus our analysis specifically on the latency from 600 milliseconds to 900 milliseconds, because many prior studies in the established literature have identified this latency at this electrode site to be a key latency in which the brain seems to differentiate these types of memory processes. So you have to give some justification, right? And again, this goes back to this idea of sort of the null hypothesis. Did you just get lucky and find this difference? It's kind of like, I mentioned a fishing expedition. Any fishers in here? Any fishermen? No fishing. No. Right, let's pretend that you guys like to go fishing. You guys like to eat fish at the restaurants, at least? Yeah, they're good. Let's pretend you're going out and catching them. And you go out to the lake, get up at about 4 in the morning, get out there about 5, spend all day fishing, you find an awesome fishing hole. You just start hitting all day. Come back with a cooler full of fish. Kind of brag to the guys at the gas station, like, yeah, look at that, you got the big fish story, right? You tell them it was this big and it got away. But you caught all these other ones that filled up your cooler. Right now you guys are going to have a big fish fry, it's going to be delicious. What might somebody say to you as you're telling that, just bragging about how great of a fisherman you are? You just got lucky. You just got lucky. Anybody can drop a line in the water, right? Yes, that had nothing to do with skill. Well, probably just went out to the store and bought it, threw them in the cooler, and came back and tried to impress us, right? I had a friend of mine. Anybody like UFC fighting? Yeah. I was friends with Chad Mendez, who's fought for the title a couple years ago against Jose Aldo, and we went out to go crabbing one night, and you take a crab trap, you put it in the water, put bait in there, the crabs come in. I showed up about midnight. We had a big campfire. We had some beers, hanging out, and what's he using to catch Dungeness crabs? He's got this big platter of what he bought at the store of this delicious salmon. And like Dungeness crabs are bottom feeders. They're like, you can catch them with cornbread and hot dogs. So he's using good crabs. So I just grabbed the crab, put it over the fire, and ate that. Anyways, so people do that. You go to the store, you buy the fish. But let's pretend that you want to say, no, this is not just luck. Okay? Didn't just get lucky. I know what I'm doing. This is a really good fishing hole. They're going to say, well, was there a reason you went to that fishing spot? You're like, well, yes, because other people went there before, and that's where they said they caught fish. All right, so that's kind of what the idea is. Is there a method to the madness of what latency you choose? You say, yes, other people have gone there before, and they've caught.
So does that mean you have to set up like the trials in a similar fashion, like the stimulus comes at this millisecond and you measure from here to there?
Exactly, yeah. So you always do it, so the stimulus is always going to show up on the screen, let's say at a certain point, and you always measure it relative to that stimulus onset.
And so those can just picture, so those are modeled after the prior experiments as well?
Yeah, although just to be, we'll just simplify it here, okay? You're right, entirely. So all you're going to do is we're always going to take this activity, okay, and we're going to time lock it to time point 0, or stimulus onset. Okay. Now you're always going to have some activity that you're also going to measure beforehand, and you're going to look at how that brain activity operates in relation to the stimulus. All right. We'll talk about this area here, your baseline area too, because that's kind of our control area where we want to basically. Well, we'll look at this activity relative to this as a control. Okay, so is that a sufficient basic overview for now? All right, so I've talked a little bit. Let's work a little bit with the data. All right, so the first thing we can do, let's just X out of here. And I might as well just jump into this. So first thing we can do, type in the letters EEGH. Okay. Wow, thanks, Ariel. Okay, so you guys see what came out here? So EEGH. One thing we can do is right-click this and copy it. So what EEGH does, the H stands for history. Okay, so you're asking the computer to give you, give us the history of what we wrote in EEG Lab, or what we did with our computer. Remember I said we're going to use the GUI? All right, but we're also going to learn how this works. So let's go to our Home tab on the left here, and we're going to hit New Script. So Home tab, New Script, click it. It's going to open up this little, looks like a little notepad, okay? Right click and paste, and we just paste that same information, okay? So let me walk you through what this means, because I said we're going to accidentally learn to code a little bit. This is how we're going to accidentally learn a little bit, all right? So what we hit with our GUI, we just used our mouse button, okay? All we did was we just loaded the data in. That's it, right? Super easy. Let's take a look. So what was the first thing it tells us our history was is we typed EEG Lab. Duh. So we know that it's right. It's tracking us. It's kind of like the NSA. Okay. Now the next thing we did is we used that biosig function to load in our data. So what does it do? We loaded in our data. Here's our directory, and then there's our file. So it's file 3.bdf, and it was within this directory. Make sense? So this isn't all gobbledygook. We're going to make it real understandable. Then it says we selected a reference electrodes. And it's the average of channels 33 and 34, which we already know is our left mastoid and right mastoid. Okay? And then we just left this on. That's just whatever. Don't worry about that. And then, okay, it has a little semicolon, so it goes down to a new line. Then remember, when it was done, it asked us, do we want to open this file and whatever? And we said yes. And we gave it a name. So it's a new data set. So new data set. Okay. It's EEG. And we named it 3_imported 3334. Make sense? Method to the madness. Okay. So. And that'll be that for now. This is just internal work. You don't have to worry about it. So one thing I like to do. Yes.
On line 5 of the bird, I'm missing that line. Does it matter?
Not really right now. These are just kind of extras for the time being.
Okay.
What I'd like to do now is and we also plotted. Remember I said plot the EEG? So it's EEG plot, and we plotted that data. So I'll just delete this because we don't need that, and I don't think I need this either. But for now, what I like to do is I like to put spaces between it, so I can read it a little bit easier, and it reminds me what we did. Okay? Yes?
So the purple part where it says C users, is that the directory?
Yeah.
And then biosig is the...
That's just the function that called that imported the file.
Oh, it's what the...
Yeah. So. Yeah.
I was just wondering.
Although I'll keep the ETL on top of right out so anyways, one thing we can do, and this is the reason I'm introducing this now. Last class I waited till like the end of the semester to start to teach you how to code and stuff. But this is a really nice way to keep track and take notes about what we did. Here's how you do that. Okay? To the right of the semicolon. So this is right. This is basically a little script that if we ran this and typed this in here, it would do exactly what we already did. But, so MATLAB only reads this as such. If we want to take notes in this, we need a way to tell MATLAB, don't read what I'm writing because these are my personal notes. The way that you do that is you use the little percentage sign. It turns the text green. I'll show you what I mean. Ready? So I type percentage, blah, 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 blah. Anything after that percentage sign goes dark to MATLAB. It completely ignores it. Okay? So what you can do is as we go through class in the semester, if you need to take notes on what we're doing, this is one way to do this simultaneously while learning a little bit about the internal code, if you're so interested. So what I like to do is use this, instead of writing blah, 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 I write up myself a little bit of note about what this is. Open EEG Lab. Over here, I'll say directory, file name, so this, everything I just kind of told you, right? Reference to the average of the mastoids. Okay, and then name new data set. Ooh. See what I mean? Isn't that helpful? All right, so we're doing this at a very basic level, so as we get more ramped up, you'll have a little bit, and we'll revisit this and we'll work on it, but it's a good thing, I think, to introduce from the first get-go. Nope, I like to, but you don't need to. As long as it's green, you're clean. All right, so let's do more stuff. So, where is my, there we go. Bring up the GUI. So the first thing we want to do, now that we've imported it, is we want to high-pass filter. What the heck does that mean? Well, let's do it and then we'll talk about it. Okay? So what we're going to do, we're going to go to, let's see here, edit? No. We are going to go to tools. Okay? We're going to do tools and filter the data. Actually, what we can do, let's go to ERP Lab and let's go to filter and frequency tools. Everybody see where I'm at? We're going to go to one filters for EEG. Raise your hand if you're not here. Okay. Bam. We hit that. It'll bring something up in a minute. There we go. Okay, so what does all this crap mean? It's a lot of stuff. You need to know about 1% of it. Okay? In fact, the 1% you need to know is down here. What did I say we were going to do? High pass filter? Okay. So let's click the button here for high pass. Let's also unclick this button for low pass. Okay? So it should look like this. Now, here's what's happening. We are using a high-pass filter. We're going to set it essentially at 0.1 hertz. All right? So what we're saying, what's a 0.1 hertz? Or let's just forget about 0.1. We talked about our spectrum over here, and we said delta was like 0 to 4 hertz. What would be 1 hertz? It'd be super slow oscillation, right? This is 1/10 of that. It's a 0.1 hertz. So this means that, so we can do this over here. Okay, so this is a high frequency oscillation, right? A low frequency oscillation would typically be like this. But a really low frequency oscillation, it would take like the whole board. I'd have to be like, I keep drawing over here, right? You guys follow? You guys follow the logic? Okay? So we don't want stuff that looks like this. All right, because basically, we'll talk about some of these artifacts. It can be reflective of drift. So when we're recording for like an hour in a session, it's kind of like you guys do so many credits and you're bored out of your freaking mind doing experiments for classes and stuff. That's what these are recorded in. College students, bored out of their mind. It's an hour in a dark room, pressing buttons for a boring memory task. You can start to have what's called skin potentials. Skin starts to sweat a little bit, you get a little warm, this and that. The electrical potential starts to drift. Okay? What we want to do is filter those really low drifts, those really low frequency drifts out. So we want to clean that data up because this is a source of noise. It's an artifact. Okay? Not like Indiana Jones artifacts. It's an artifact like crap in data. Okay? So we just apply the high pass filter and it filters out anything above our value. Now our value, or excuse me, anything below our value, which sounds opposite of high pass, but our value is 0.1, which means it allows anything higher than this value to pass through and be kept. Anything beneath here, any of these low, slow drifts, filtered out. So let's just do that and hit apply. You don't have to, yes sir.
I accidentally exited my GUI.
Okay, so bring up the GUI again and I'll show you how to do that. So this will take a moment or two to work because it needs to think. Okay, so what we have here is it's done with that. So it asks us what do we want to do with the data set. So we want to have a little chat with the computer and answer its question. It says, what do you want to do? Guys, pay attention. So you have, this is our data set, and it added something at the end of it, filter. So now we know that it was filtered. Okay? So what I like to do, and then so the way that this works is we can name it, and it becomes an extra data set up here, but we can also save it. Okay? So if we save it, then it also becomes a data set, but now it's actually saved in our folder too. And it'll be this folder that we sent it to. Okay? So why don't we do that and just also check the box for save as file. And you can just copy that name and paste it in there. Just hit OK. You guys good? Anybody not do that? I know you're still loading it up, but let me know when you're back up to speed. And so case in point, this is one reason why it's really useful to have our history here. So when you need to go back and redo it, you know exactly what you did, right? And what you can do is you can just highlight this and hit run, or where'd it go? Evaluate current section, or run here, and it'll load that in and do that for you and replicate what you already did. Nobody do that except for him, but it'll just goof things up. But yes, Val.
I have on the window that we're chatting. Some changes have not been saved. What do you want to do with the old data set? Overwrite it in memory or save it as file?
I would just overwrite it for now. It's fine.
Could you do this part again, please?
The filter?
Yeah.
Okay, so
Well, not the filter, just the. Yeah.
okay, so we just did the high pass filter. Yeah. So let's say you need to do it again. This is a great example. What do I do? So this is our file that finished that we just did. It's filtered. Let's go back one step. So this is what's really nice about EEG Lab. It keeps this. We go back one step. Okay. We went to ERP Lab. We went to Filter Tools, Filter for EEG. And we took off the low pass and we applied the high pass.
I think you just applied the low pass.
Huh?
You just applied the low pass.
Oh, yeah. Well, I guess, yeah, it had memory for what I did. Thanks for catching that. And you just hit apply. And then you'll do the saving function. So it runs, blah, 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 it thinks. It'll ask us, what do we want to do? As it thinks. Now, I'm running this again, and it'll ask us this. And I've already done this, and you do that. Make sense?
You just press OK.
Well, what I did was I copied this. Then I hit this button here to save this file, and then I pasted the same name, and I hit OK. So now for me, I have 3 data sets because I just did that twice. But what we can do is if we come back in our command window, I'll type EEGH again. Now we've got some new information. Okay? So I can highlight that. I can bring it back in my editor. Okay? I can paste that in. Okay? And I can type in high pass filter. Now let's take a look at what it's telling us happened. Yeah. It just says basic filter, EEG to all of our channels 1 through 38. Forget. Our cutoff is 0.1 hertz. It's a high pass, and it saves it as data set number 2. Okay. Now, what we also did is when we were here, we then saved that as well. And so here, it also shows us the command that we did to save it. So now it says we have a new data set. I'm going to save it. What's the name that we save it with? It has that filter at the end. And that's it. Yes?
Line 11.
EGH.
Okay, I see.
Make sense?
Yeah, I have it.
Yeah. So this is a way to take digital notes if you don't want to take them by hand of what we did. Okay, so let's say my computer crashes, or he says, I forget your name? Arturo. Arturo goes, oh man, I lost this and this, how do I do this? You can just literally rerun this script and it'll take you back to exactly where you were. So it's good to keep records of what you do. Let's go back to what we have. Yes? Can you send that louder? Okay, so she asked, what do I mean by rerun all of this? All right. So first of all, what I'll can I come back to your question just a second? Okay. What I'll have you guys do is let's take a look at what happened now when we did that. So we're on, let's say, data set 2, right? It has our filter, and so we see our name here. See where my mouse is? Everybody paying attention? Okay. Now we have this, and remember when we plotted the data before, it looked all crazy because it was like you only saw a couple traces? Well, that's because, why did we need to scale that big? Anybody have ideas? We went to like 500 on the scale, right? It was massive. Well, because there was such massive drift, too. It's drifting across an hour-long recording. So even though it's a small little oscillation, they're going huge. You guys remember seeing that in our lines? Okay. Let's see if this changed it. So let's just go back with that data and just go plot channel data scroll. Oh my gosh, what happened? Pretty cool, right? So we can see the effects of our processing. Okay. Look at our scale. Now we're back at 83. And we have all of them on the same page. Does everybody have something that looks like this? No. No? Who doesn't?
Frozen.
Frozen?
Our computer frozen.
Let it go. Just let it go, man. All your life has been like a series of doors closing your face. Okay? And I don't know if it's the party talking, maybe chocolate fondue, I don't know. But, we'll see what happens. Okay. If it's...
They just press Control V and then it ran something.
Well, so you froze. Let's pretend that mine is frozen too. And I've got to rerun this. This is going to answer your question I said we would come back to. What do you mean by rerun this script? Okay, let's take a look. I will X out of here. You guys can just watch what I'm doing. Okay? And we will go. I will do my scripts that my little shortcuts. I'll CLC. I will clear all. Watch what happens in my workspace on the right. Wah, wah. Now I'm screwed. Data's gone. Clear it all out. Everything we just did, SOL. You guys know SOL?
Yeah.
Okay. Now I'm screwed, right? Let's say I need to rerun things. Let's bring up, I don't even need to press the EEG Lab button. Let's bring up that script. What do I mean by rerun it? That was the question. Right, madam? Or ma'am? Let's say that I just want to load that data in. I will highlight this, and you can press, so right now if I highlight this, and if I press the button F9, it means run, or I can just do this here. I hit the run button, or run section, and when you do that, it will evaluate that. So what's happening is, notice that I didn't type EEG Lab in, did I? I didn't have to. It's already typed in here, and when it's there, it's automatically brought up our GUI, and then I didn't have to load the data in because it's already doing that. See all the steps it saved me? It's pretty nice, right? Yes.
Can you just take down on the whole thing?
Well, I want to do it spot by. You can do the whole thing, but we have a couple spots in here that I basically didn't want to run. So I just wanted to show you stuff section by section, because a lot of times this is also a way that you troubleshoot a script. So sometimes you'll get a script, or you'll be writing one, and you'll get error messages, and you'll be like, oh shit, this doesn't work. When it doesn't work, the way that you troubleshoot it is you do evaluate section by section, and you say, okay, let's just try this section. Okay, this works. All right, let's go down to the next section. You keep doing it, and that's where you find out where the error is. So that's one reason why I just did it spot by spot. Yes, sir.
Well, would run in advance do the same thing?
I don't even know what run in advance does. This is like a new version of MATLAB that I'm not very used to. And it advances to the next section or something. I mean, to be honest, it could. I've just never run it. So what I know about MATLAB is like a swip. I mean, MATLAB is a beast in itself in a good way. It's awesome. It's this whole different, it's like a whole matrix you can jump into and be a red pill or blue pill, whatever. There's a lot to know about it, and I know what I need to know, as in my little world. I just haven't seen that. I just haven't bothered with the button. Probably just a slight difference. Okay, so let's see here. It's still thinking. Right now, remember, it took us a while for her to stop thinking on this, because we're importing this massive first data. Okay, and then once we start saving it in EEG Lab format, it's gonna get smaller. Yes, sir. Question.
Can I do a run section on that? It's saying it's invalid.
Well,
Invalid statement. It might be.
Okay. Since we're talking about coding a little bit, have any of you guys done computer coding or programming before? A little bit. Okay, so you guys know a little bit about that. Is there any such thing as a stupid computer? Usually, whenever there's an error, if the computer's screwing up, what it means is that we screwed up on something. Computers don't do stupid things. They only do exactly what we tell them, and they're really, really good at doing exactly what we tell them. So sometimes it's because we had a little error or something like that, and that's okay. Okay, so for one thing, you do need that. Okay? Oh well. Let's see. Okay. That's no. I would do what I did, which is CLC, clear out, but don't do that because you have your stuff as it is. Okay. I'm just showing you exactly. Alright, so are you set up? Yeah, it takes some time. Okay, so, all right, so most everybody has successfully high-passed their data, right? Yeah? Okay. We can see that mine is working in the background too, and we've already done that. The next thing that we can do is we want to save this file as a smaller version. So we sample, we record our data. Remember we said we sampled at a very high rate, 1056 hertz? Okay. Let's see here. So, when you have data, we're always talking about sine waves, right? You guys follow? We sample, and we measure that. By sample, we mean how often do we measure it? Do we measure it every now and then? What would it look like if we measured that data at that frequency, where those dots are? It would look like those dots. We would have to connect them. It would look like this. Does that accurately represent the brain activity that was happening then? No. You're sampling way too low, right? What you want to do is sample at every single, you want to sample at all these different times, right? That way when you plot that data, it actually represents all that. You guys follow the logic? Okay. So we recorded at 1056 hertz. All right, so an incredibly high frequency. We don't really need it that high. It keeps our file sizes massive, which is one of the reasons it takes so long for it to think. Okay, we want to downsample it. We're going to bring it down to 256 hertz. It's going to make it a much more manageable size. All right, so what you can do is you can go to, you're going to go to Tools and Resample. So mine's thinking, so you can't see it on here. But go to Tools, and it'll say Resample.
On the GUI?
Yeah, on the GUI. And I'll take a look at,
Change sampling rate?
yeah, or change sampling rate. And when it goes to change sampling rate, you're going to simply type in 256. And you're going to press that lucky button, enter or OK or whatever it is, that where all the magic happens. And it'll think, probably not very long, and it'll bring up that other prompt again that's going to ask you if you want to save this file or whatnot, and it should ask, it should put a suffix on our file that says resam or something like that. Yeah, no? 256. Okay, and so you guys notice how the computer is being really helpful for us in all of our file names, because it always adds a little description about what you did to the data. So next week, when it's Thursday night, you're trying to get ready for class today and prepare for your quizzes or what I might ask about what you should remember about what our processing steps were and things like that, and you want to work with your data or know what's done with it, you might have forgotten everything you did. So when you're loading the data, or you don't even have to load it, you can look at the file name and it'll tell you this is what was done in this short version. This you'll know that you brought it in, it was epic, or no, it wasn't as epic, it was imported to those reference sites, you filtered it, and then you resampled it. Okay? I like to do that process where we name it and then save it as the same, and you can often just highlight Control-C, Control-V, so you type it into, and do that and just hit OK, so now you have this new file. So that's not going to change much of how the data looks and when we plot the channel data or scroll it, but it will change the size of our file types. Okay, so if that actually brings us to a good point about file types. So if you look in our window on the left, okay, over here, where our current folder is, we can see that there's all these files, right? And you'll note that we have things that look like this. Now, we started with a BDF file. That's our raw data. And once we've imported it, we'll never use it again, because it's way too big, it's way too slow. Look at how long it's taken to even work with this. We need to get fast. Okay? So we did start with this, but now once we import it and we saved it and we filtered it, and when we saved it, it actually creates two files. But notice that they have a different type of suffix, right? One is .set and one is .ftt or D2. Okay? So you always get two sets of files for that subject saving. Basically, the way that that works structurally within MATLAB is that it's one of those files is just like a header file, which is like the name and some structural organization of the data. So it's very, very small. And the other file is actually the big, chunky data. So it always saves two. So you'll see that in your file directories. And it's not, if you note that they're not the same types of files. Okay? So you'll have that, and now we'll work with the resample data. So let's see here. This is actually still thinking on me. I'd like to move past this particular aspect. So what I'm going to do is I'm going to X out of that. I'm going to come here. All right, are there any questions? Still frozen? That's actually what's happening to mine right now. I come in here, and what you can do is do Control C or Control X. It should help to stop it. If it's super frozen, you can Control Alt Delete. And you can bring up the task manager. I can do MATLAB and I can end it, and I can restart it. And that's probably what I'll do too to bring it around. What's that?
I don't have task manager.
You gotta have a task manager.
I don't.
You have like the redheaded stepchild of computers. Oh my God, seriously. I guess a lot of just try to no, you're getting just
No, it's been frozen. I tried to it came up and then I tried to exit out of it.
all your like really has-been series has stores in your face.
Let me see if I understand that. Because I, in this whole time, have been downloading the different versions of MATLAB.
I mean, restart
And it's still giving me the same
Okay.
error. Oh, you know why? Because it's not phenomenally too
Get here every day.
You should, yeah, so very basic, it's the same thing you started with. So be able to open MATLAB. Other purposes, it's also but it's fine. The first thing that we're going to do.
So I'm gonna try like every single word.
Yeah, you already did 2014 is okay. I think the problem for one of the choices is like for 2015 is you have
Set that,
to
then you want to set that, and then
no, it doesn't make sense because you have the right version of to that. I still have the wrong version of that, so I have to change that stuff because apparently the older version. Don't use 14, and if you do download 14, don't use 14. I don't know what's going on there.
So if you use 14, do you use that 12 it's not
which is again,
yeah, and that's the thing that came out that I had a problem with, we designed a low.
Something I have to ask.
Go to data sets.
But it is not also.
It's not loaded. So when it finishes loading, okay. When it's done, click on data sets, it should be there. And
Yeah. Okay.
Okay.
Because there's like a student version, there's a lab version. I don't know if this is student version. Well, does it work with all of the plugins then?
Okay, so what's that?
Well,
Well, I shut it. I went to the task manager and shut it down and just reopened it. Like you might need to just restart or log out or log back in or do something because I don't. Okay, so here's the thing, right? I just had to reboot for a reason. It froze up. All of its life was a series of doors closed in its face, and I needed to unfreeze the computer. So let's say that now I want to load up and I want to catch up to where you guys are at. Okay, what I do is I don't have to start from the bottom where we started at before. Screw Drake, leave him behind. He's not even good at dancing. And have you seen his dance video? It's awful. The little one where he's what?
They changed it. Like you can't find it.
Yeah, you can't. He's too embarrassed. He took it down. Yeah. Okay. Do you guys want to see something funny? Do you guys remember? Everybody here has been in behavioral neuroscience, right? Everybody knows what the sodium potassium pump is. Do you know this?
I know exactly.
Did I send it to you?
No.
No, you might have sent it to me.
I've seen it for sure.
Yeah. Okay. So you guys want to have some fun? So I said we take like a 5-minute break in class. This will be our 5-minute break. Okay. Check this out. Okay. So let's do Drake, sodium, potassium. I don't know. Let's see if this. Nope. It is Drake, right? Yeah, where is it? I don't know if it's I saw it as a GIF, but let's see. I can't find it. Where'd it go? I hope they didn't take that down too. This is not it. I'm trying to find something good. I can't get it. Maybe this is it. Yeah. Okay, so you have the extracellular membrane and extracellular fluid and the intracellular fluid. This is our cellular membrane here. Okay? You have 3 sodiums, 2 potassiums, and ATP. And that's Drake jamming out. You guys get it? Huh? That he looks silly?
I mean, like, they spent so much time putting it together, like, no one said a thing.
It's like a Zoolander thing, right? You just like taking pictures of the person acting silly. Nobody told him that he looked like a monkey in Zoolander, right? He's just jumping around like a... Anyways, that's pretty good, right? Come on, man. We can geek out on this, right? Huh?
If we're learning to code, we can geek out.
Yes! Yes! This is sodium, potassium, and whatnot. Alright. Alright. So that's that. Sodium, potassium. So let's take a look here. I mentioned that let's say that I want to catch up to where you guys are at, right? So Arturo, we got to catch up, right? Let's say that I had to shut my computer down. It was frozen like the movie, and I got to catch up to where everybody else has burned me in the dust on, okay? So because I saved what we did, because I saved those files when it asked us to, I don't have to go back like Drake and start from the bottom and start with the PDF files that take a long time to load in. I can go straight to this file, 3 imported 3334, that we already filtered, and I can just load that in. Okay? So I just loaded it in. We can revisit that. I can just type EGH in, and look, all it does is just show that one simple thing that I did. Okay? New script, paste. All I did, I just typed EEG Lab. I loaded in our file. It says what is our file name. It says what is our file path, our directory. And then this just shows that it's like rebooted back up in, so it's ready to go. Now, what you guys did was you all, or y'all as we might say in Texas, right? You guys resampled it. You downsampled it to 256, so I'll catch up with you, and I'll do that right now. Change sampling rate. Make that 256. Okay. 256 hertz. It's cooking up down here. It's showing us exactly what it's thinking. It'll be done in a second. We save it as resampled this way, and I'll add the same name to it. This way, in case we need to come back to it, it's already done and ready and accessible. So here we are. Okay, so now I should be very similar to where you guys are at. We should have a file loaded, the subject number imported 3334 dash filtered resampled. Make sense? All right. So what do we want to do from here? So this is all within our what we're going to call pre-processing. So what we're doing is we're just getting the data ready for being able to do more advanced things with it. Because what does it tell us here? So we already know about what it's telling us about our channels per frame. We have 38 channels. And we know that we have only one epoch, right? We have this long period of our singular hour-long recording. But you guys remember I said that we need for us to get what we need to get out of it, we need to slice it into certain events, right? We want to know we want to take that special opportunity that we have in the modern era to take a snapshot of a window inside the brain. Very, very rarely in human history we have this ability at our fingertips, and we're going to do that. We're looking at it right now with this data. We want to know what's happening in the brain during different times of cognition. When we're remembering, when we're forgetting, all these different types of things. We want to be able to look inside brain activity and figure that out. And if you just have one big long stretch, that's not going to tell you anything. We need to be able to slice it into different times so we can categorize that activity based upon the different types of cognitive phenomena that's actually occurring. Does that make sense? Okay. So what we want to do is we want to slice it into our 300 trials. Now we have 900 events. Okay. One thing we can do. So this is a good time to actually talk about what is our experimental paradigm. Okay. So actually, let me take a look here. Let me open something here. So I'm opening the script that you have a copy of. You don't have to open it. This is a much more complicated script, but let's see here. I'm going to do this. One thing that I'm going to do is I'm going to do so we have some events that I'm going to try to take out. And what this says is I'm going to run this little command. It says select certain events It says omit, ignore, delete, do something, omit these types of events, and they're going to be called 1 to 5. And it's going to say, do we want to delete these events? We're going to say yes, turn delete events on. Okay? What the heck am I talking about? When, I'm going to actually turn these lights on so I can draw the board a little bit more clearly for you. I'm going to introduce our memory experiment a little bit more detailed. And we'll go into even greater detail next week when we have more time to talk about it. But subjects look at a computer screen, and let's say there's a word on the screen. And let's say that word is frozen. Okay? This stays on for t minus 0 to 1500 milliseconds. Okay? And you just see the thing on the screen. You're either going to remember that you saw it before during class or that you didn't. Then, the same word is on the screen, and people are asked in the experiment to say, do you remember this word from our study phase, or do you not? Is this an old word that you saw in the experiment earlier, or is this a new word? So, old or new. But, kind of like a doctor's office, we want them to rate their pain. But not pain in this case, but rate your memory on a scale of 1 to 5. 1, 2, 3, 4, 5. We'll talk about that in more detail next class as to why this is such a powerful way to measure memory. But for conversation purposes today, just know that it gives us more insight into the different types of memory processes that are operating. So what it allows us to do is look at different brain activity for times when people are really sure they remember it versus those other times when they think they remember it, they're just not completely sure. Right? Now, we experience that in our everyday life, so we know that that's a pretty valid memory phenomena. It allows us to look at the neurobiology that's associated with those different cognitive phenomena that we all experience, right? Some test questions were like, yeah, I nailed it, I know exactly the answer. Other times we're like, I think this is the answer, right? And other times they're like, I don't know. Okay? So it allows us to do that. So we have an event that starts here. So we have to note in our EEG, during this occurrence, when does our stimulus show on the screen? We use a code, okay? 61 is an event code. That means it's an old item. Okay, 62, it's also an event code. That means it's an old item. And then 63 tells us it's actually a new item. Make sense? Okay. And we'll talk next week about why these are different. But pay no attention to that right now. Yes, ma'am?
Are the numbers specific for like this experiment, or is that all of these?
It's just for the experiments we'll work with in this class. Because I invented this. I mean, when you design a study, you just have to decide what numbers you want to represent what. So you just cook it up here. So you can make it different for any other studies. This is just for hours for this class. Okay? So this might be, you're going to have an event code here that's 61. Okay? And it's integrated into the EEG. Now here, okay, we have when they press, let's say 5, the rating 5 becomes integrated into the EEG. I'll get you in 1 second, okay? But afterwards, there's a second decision we have to ask them to make. The word stays on the screen. The numbers stay on the screen. But now they're actually, so we call this your item memory. Okay, because we're asked about this item. Here, we're actually asking them for their source memory next. So where, okay, so you remember this, great. Do you remember what part of the experiment it was in? Was it from the part of the experiment where you were asked to make judgments about if it was pleasant or not to you? Or was it from this other part of the experiment that you were asked to make a judgment if it's alive or not? Okay, well, we'll get to that details later. Just next class, just know that we asked what's called source memory. Okay? And if it's from, let's say, source 1 or source 2, and of course here they would say, I don't know, can't remember. We'll talk about the cognition for this stuff and the theories and why next class. But today, I'm introducing this to note that when, let's say they say, let's say they can't remember. So then they say 3. Okay? So in our experiment, we have 200 old items, and we have 100 new items. Okay, so we have a total of 300 memory instances where they either remember or forget. Okay, now it's important to put the new ones in there too, so they're not cheating you and they're like, yeah, I remember that, I remember that, I remember that, and they just hit yes, 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 yes to get the heck out of the soda credits. Right? You want to keep some new ones in there to keep them honest. This way, you guys follow the logic? So you have 300 trials, but for each one of the 300 trials, there's 3 events. 1, 2, 3. 300 times 3 is our 900 events. Told you there was a method to the madness, right? So what we want to do is we only care about these 1500 milliseconds of EEG. Because when they're giving their motor responses, we don't want their motor cortex activity of their fingers pressing buttons. We don't want them yawning, stretching their head, moving around, going, oh, geez, yeah, I don't remember that, blah, blah, blah. We only want the clean brain data from here. Okay? So what we need to do is we're going to delete this and this. Okay? And the reason we're deleting it is because, as a favor to you, what I did beforehand was I took these codes and I made sure that we don't forget what this information is, because I said, I went and worked with the data 8 years ago, and I made it so that this code now reads as 6153, which means it's an old item, their item memory was a 5, and their source memory was a 3. Okay? There might be quiz questions on this stuff later. Know the structure of the experiment. Know what the codes mean. Yes?
So on that scale of 1 to 5, on both source 1, source 2, those are the scales. So 5 would be completely sure it's an old one, 4 is an unsure, 3 is you don't know whether it's either or, 2 is unsure if it's a new one.
Exactly. Okay? So, moving forward, it will be important in the class that you have a good understanding of these codes. Okay? Because it's our translation to provide insight into the neurobiology of our conscious experience. Okay? So it's really pretty important. But anyway, so we have this code, but we have these extra ones that we need to delete. So that's what I'm going to do here. That's why I took this code here, and I just said I want to delete these events. Okay? And then I'll hit F9. It runs. So now, let's see here. We can now do something like, let's do, might be able to extract bin-based epics. Oh, can't do that. Yeah, are there questions on this stuff?
I have a quick one.
Yeah.
What are the frames per epic? I noticed it changed from like 3 million.
You know, I'm not entirely sure, to be honest. It's not something we ever really deal with. So no need to worry about that. Yes, Val?
So just to make sure, 61 is an old item, 5 is sure there is an old item, and 3 would be unknown about the source.
Yeah, so another way to think about this is to just know that we have a 4-digit 4-digit code for every event. Okay, so you have, let's say, 6153. Okay, so we have a 4-digit code. Our first 2 digits is either old or new. Our next digit is item memory. And it's actually item memory confidence. And our next one is source memory. Confidence. Are there questions on this? Do you see how it makes sense? I hope that it's making sense. Because it's going to allow us to start parcellating things out. And then just so we know, we actually have our old information, one of which came from what we're going to call an animacy judgment. So they saw an item on the screen during the learning phase, and I simply asked him, is this item alive or not in real life? So he saw a marker. Say, no, that thing is not alive. It's not a living thing. He saw a flower. And I said, yes, that's alive. Flowers are alive. Really stupid, silly things. The only reason you ask them to make these judgments are, 1, make sure they're not sleeping on you in the experiment. Okay, you want to keep people awake. And 2, it allows us to ask that source memory question, because we also ask them a different type of question sometimes. Is this item man-made or not in real life? Okay, so that's basically, is this item a man-made item? So you look at the marker, you're like, yeah, that's a man-made thing. If you look at a flower, you're like, nah, flower's not man-made. Again, it's stupid, it's simple, it's quick. It keeps them paying attention, so you know that they're encoding the information. And it allows you later on to ask their source memory. So yes, I remember seeing that. Great. Do you remember if it was part of the experiment where you were asked to make this judgment or you were asked to make that judgment? You're like, oh shit, I don't know. It's hard. As scientists, it gives us a lot of leverage and power by which to gain very detailed information reported back from people about their memory experience. And then we get to see that in the brain activity. Okay? So 61 equals that, and 62 equals that. Now, of course, 63 is a new item. Make sense? Okay. And then, of course, this is going to be either 1, 2, 3, 4, or 5. This is going to be either 1, 2, 3, 4, or 5. Now think about all the possible combinations that exist. Right? All the combinations between this, any of these responses, followed by any of these. It's about 75 combinations. No, it might even be more, actually. No? Any questions? Yes?
Could you say how many old and new events there were?
Oh, yeah. There's 200 old and 100 new. Why? And I'll show you exactly the reason why. So there's 100 of these, 100 of these, and 100 of these. So, of course, you have 200 old. Alright, so what I'm going to show you now is something